Friends, welcome back to my YouTube channel. So in today's video we'll see a problem which is having the 4 points, but see here span BC has no supports. But in previous video also we have seen a problem which is having the 4 points, but in that there is a support. I will show you. We have already solved 3 problems on this topic. In previous video we already solved one problem which is having the 4 points, but in that problem there is a support. But in this problem, see here span BC has no support. So today we'll see how to solve this. I will show you in previous video we have solved a problem which is having the 4 points. See here, but it is having the 4 points, but there is a support at middle. But in today's problem there is no support in middle. So this problem also I will give the link in the description box. You can go through this video. So today we'll see a problem this problem. This has no support in middle. We'll see this problem. So as usual, our first step is to solve the fixed end moment in slope deflection method. We all know. So we'll see. So our first step is to find out the fixed end moment for span AB, BA, BC, CD. So we'll see. For our first span AB is having the UDL. For UDL we have the formula. See, for UDL we have the formula MFAB is equal to minus WL square divided by 12. MFBA is equal to WL square divided by 12. By using these two formula, we'll calculate the fixed end moment for span AB. We have the formula MFAB is equal to minus WL square divided by 12. It is anti-clockwise, so our load is 30, it's given, and L is 6 meter. So 6 square divided by 12. By simplifying it will come out as minus 90 kilonewton meter. So similarly for MFBA, we have the formula WL square divided by 12. The formula is same, but only the thing is sign will change. So answer will come out in positive, that is 90 kilonewton meter. So this is for span AB. Similarly, we'll see the for span BC. For span BC, the point load is acting, which it's acting at the center. For this, we have the formula, the point load which is acting at the center. For that, we have the formula MFAB is equal to minus WL divided by 8 and MFBA is equal to WL divided by 8. So by using these two formula, we will calculate the fixed end moment for span BC. For that, we have the formula MFBC is equal to minus WL divided by 8. So minus our load is 15. So 15 into L is 8. L is 8 divided by 8. So by simplifying it will come out as minus 15 kilonewton meter. Similarly for MFCB, we have the formula WL divided by 8. The formula is same, only sign will change. So it will come out as 15 kilonewton meter. So positive. So now we'll go for the span CD. Calculate the fixed end moment for CD as well as DC. So it is having the point load which is not acting at the center. So for this we have the formula, the point load which is not acting at the center. We have the formula MFAB is equal to minus WAB square divided by L square and MFBA is equal to WA square B divided by L square. So by using these two formula, we will calculate the fixed end moment for span CD as well as DC. So now we will see MFCD is equal to, we have the formula minus WAB square divided by L square. So our load is 10 here. Load is 10 into A is 1 and B is 5. So 5 square divided by L is total 6 square. length is 6 meters, so 6 square. So by simplifying it will come out as minus 6.94 kilonewton meter. So similarly for MFDC we have the formula minus W A square B divided by L square. So L is, this is plus not minus. So our load is, load is 10. 10 into A is 1 square and B is 5 divided by L is 6 square. So by simplifying it will come out as 1.38 kilonewton meter. So this is the fixed end moment for span DC. So now we'll, so this is our first step. Now we'll move towards the second step, that is to find out the slope deflection equation for each span. So by using the formula these two, by using these two formula we will calculate the slope deflection equation for each span. So we'll see. So step 2 is to applying the slope deflection equation for span AB. For that we have the formula MAB is equal to MFAB plus 2EI divided by L, 2 theta A plus theta B minus 3 rho divided by L. So here in our problem the deflection value is not given, so it becomes 0. We are not going to write this one, it's become 0. So now our MFAB we got was, for MFAB we got was how much? Minus 90. So minus 90 plus 2EI divided by our AB span length is 6. So 6. Here 2 into theta A is your fixed end. So at fixed end our theta value is equal to 0. See, fixed end theta value is equal to 0. So 2 into theta A becomes 0. So I am not writing it. So theta B, there is some value here. So we need to write down as it is theta B. So now, so simplify this. It will come out as this MAB is equal to minus 19 plus 0.33 EI theta B. So call it as equation number 1. So similarly for MBA, so MBA we have the formula. This one. So MBA is equal to MFBA plus 2EI divided by L, 2 theta A, 2 theta B plus theta A minus the deflection value is not given, so I am not writing here. So now substitute all the value. So our all the value MFBA value we got was 90. So 90 plus 2 EI is constant as it is. So L is 6 meter. 2 into theta B as some value. 2 into theta B. Theta A is fixed end, so it's become 0. So at fixed end theta value becomes 0, so I am not writing it. So simplify this. It will come out as MBA is equal to 90 plus 0.66 EI theta B. So call it as equation number 2. Similarly, apply the slope deflection equation for span BC. So now we'll see. For span BC, I will type MBC is equal to, I will directly write the again. So again we need to use this formula. In case of AB we need to put BC. So in case of AB, we need to put BC. In case of A, so put B. In case of B, put C. So MBC is equal to MFBC plus 2EI divided by L2 theta B plus theta C. So deflection value is not given. I am not writing this value. So now simplify this. So MFBC value we got was minus 15. So substitute that minus 15 plus 2EI divided by span BC is 8 meter. So 8. 2 into theta b has some value plus theta c is also have some value. So now simplify this. MBC will come out as minus 15 plus 0.5 EI theta b plus 0.25 EI theta c. So call it as equation number 3. So similarly we'll calculate the MCB. So now we'll see. So MCB we need to use this formula. In case of BA we need to put CB. So in case of B, C. In case of A, B we need to put. So MFCB plus 2EI divided by L 2 theta C plus theta B. Deflection value is not given. I am not writing here. So MFCB value we got was how much? So we got MFCB value 15. So put this value there. MFCB 15 plus 2EI divided by L value is B. So L value is 8. So 8. 2 into theta c, it has some value. Theta b also it has some value. So simplify this. Our MCB will come out as 15 plus 0.25 EI theta b plus 0.5 EI theta c. Call it as equation number 4. So similarly for span CD, we need to apply the slope deflection equation. We'll see. For MCD, we need to use again this formula. In case of AB, CD, put CD. So in case of A, put C. In case of B, put D. So MCD is equal to MFCD plus 2EI divided by L 2 into theta C plus theta D. So substitute all the value. So our MFCD value we got was how much? So MFCD we got was minus 6.94. So substitute that value minus 6.94 plus 2EI is constant. So L value is total 6. C span is, it is 1 meter and 5 meter, total 6 meter. So 6. 2 into theta c, 2 theta d is fixed. Theta, so point is it is fixed, so our theta d value is 0. So I am not writing it. So simplify this. Our MCD value will come out as minus 6.94 plus 0.66 EI theta c. Call it as equation number 5. So similarly we'll calculate for MDC. For that we have the formula. So we need to substitute this formula. In case of BA we need to put DC. So in case of BA we need to put DC. So now we'll see MFDC. So MFDC plus 2EI. MFDC plus 2EI divided by L 2 into theta D plus theta C. So this is our formula. So now our MFDC value we got was how much? So MFDC we got was 1.38. So put this value there. MFDC 1.38 plus 2EI divided by L is 6. So 2 into our theta D is fixed end, so it becomes 0. and it becomes 0. Theta c, it has some value. So simplify this. So our MDC value will come out as 1.38 plus 0.33 EI theta c. So call it as equation number 6. So this is our second step. So we have completed the second step. Now our third step is to equilibrium condition, applying the equilibrium condition. See here, our point is 3. So for 3 points, we have the equilibrium condition. Last video also I have explained. So our for 3 points, we have the, wait, I will
See here, this is the 4 points being, but we have the condition for the 3 points, that is ABC. This is applicable only when we have the 3 points, but in our problem we got the 4 points. So what we have to do is,
here, but here we have the 4 points. For that we have to, what we have to do is, first we have to take these 3 points A, B, C. We need to apply equilibrium condition for these 3. For ABC we have the equilibrium condition. We have the equilibrium condition MBA plus MBC is equal to 0 for ABC. And second we need to add this, and we have to take the BCD. So for BCD we have the equilibrium condition
MCB
plus MCD is equal to 0. So this is our first condition, this is our second condition. We need to apply these two condition when we got the 4 points problem. We need to do like this. So now we'll calculate by applying these two condition. So remember, whenever we got the 4 points, we need to apply like this. First we need to take the first 3 points, and later we need to take the remaining 3 points. We need to apply the equilibrium condition for remaining 3 points. This is how we need to apply. So now we'll see one by one. First, third step is to applying the equilibrium condition. So MBA plus MBC is equal to 0. This is our first condition. And MCB plus MCD is equal to 0. So this is our second condition. So our MBA value we got was, see here, MBA we got was 90 plus 0.66 EI theta B, and MBC we got was minus 15 plus 0.5 EI theta B plus 0.25 EI theta C. We need to add these two. So I will write here, our MBA value we got was 90 plus 0.66 EI theta B minus MBC we got was 15 plus 0.5 EI theta B plus 0.25 EI theta C is equal to 0. So simplify this. By simplifying, it will come out as 1.16 EI theta B. When we add 0.66 EI theta B plus 0.5, it will come out as 1.16 EI theta B plus 0.25 EI theta C, and 90 minus 15, it will come out as 75. So I am
taking it to right side.
It becomes minus 75. So this is the equation number 1. So similarly we need to apply second condition, that is our MCB plus MCD is equal to 0. So MCD is equal to 0. So MCB value we got was 15 plus 0.25 EI theta B plus 0.5 EI theta C, and MCD value we got was minus 6.94 plus 0.66 EI theta C. So by applying these two, we'll calculate MCB we got was 15 plus 0.25 EI theta B plus 0.5 EI theta C minus MCD we got was minus 6.94 plus 66 EI theta C is equal to 0. So simplify this. So by simplifying it will come out as 0.25 EI theta P and 0.5 EI theta C plus 0.66 EI theta C. It will come out as 1.16 EI theta C. So it's equal to 15 minus 6.94. It will come out as 8.06.
So I am taking it to right side.
Becomes minus 8.06. So call it as equation number 2. So what we have to do is add equation number 1 and equation number 2 to get the value of EI theta B as well as EI theta C. So I will show how to calculate EI theta B as well as EI theta C. So what we have to do is mod 5 1. So now our value is 1.16. So add it 1.16 and 0.25. So 0.25 and minus 75. So minus 75. So our equation 2 is 0.25. So 0.25 and 1.16 minus 8.06 minus 8.06. So now solve it. So our x value is nothing but our EI theta B value. So EI theta B value we got was minus 66.23 and EI theta C, for that we need to solve one more time. It will come out as 7.32. 7.32 is our EI theta C value. So this is how we need to calculate EI theta B as well as EI theta C. Now substitute this EI theta B and EI theta C value in our equation 1, 2, 3, 4, 5, 6 to get the final moments. So I will write here all the equations. So our step 4 is to find out the final moment. So for that we need to substitute EI theta B and EI theta C value in equation number 1, 2, 3, 4, 5, 6 to get final moments. I have written all the equations here. Now I will calculate MAB is equal to minus 90 plus 0.33 EI theta minus 90 plus 0.33 EI theta B value we got was minus 66.23. So simplify this, it will come out as minus 111.85 kilonewton meter. So this is our MAB value. Similarly for MVA, 90 plus 0.66 EI theta B value is minus 66.23. Simplifying, it will come out as 46.28 kilonewton meter. So for MBC, minus 15 plus 0.5 EI theta B value is minus 66.23 plus 0.25 EI theta C value is 7.32. So it will come out as minus 46.28. It will come out as minus 46.28 kilonewton meter units. So MCB 15 plus 0.25 EI theta B is 66.23 plus 0.5 plus 0.5 EI theta C value is 7.32. So it will come out as 2.10 kilonewton meter. So this is for MCB. For MCD, minus 6.94 plus 0.66 EI theta C value is 7.32. It will come out as minus 2.10 kilonewton meter. For MDC 1.38 plus 0.33 and 7.32, so it will come out as 3.79 kilonewton meter. So these are our final moments value. This is our step 4. So now our step 4 is completed. So next is to find out the support reactions. For that, what we have to do is, so to find out the support reactions, here we have only two supports here. Here reactions RA and here RD. We have only two support. For this we don't need to calculate separately. So we'll calculate by taking the moment about A and summation of Fy. We need to calculate the reactions RA as well as RD. So because our BC has no support, so for that we need to only two reactions will come. One is RA and second one is RD will take place in this particular problem. So because of our point B and C has no supports, for that we don't need to calculate separately. I will show how to calculate it. So this is our given beam. Here RA takes place reaction, here RD takes place. For that we need to take the summation of moment about A is equal to 0 clockwise positive. So before this, here moment will come. I will show it. Here moment MAB. So MAB value we got was minus 311.85. So it is negative, it means it's anti-clockwise. So 311.85, we don't need to write here negative sign because the symbol itself indicates that it is anti-clockwise. So for DC we have the value 3.79. It is positive, it is moving clockwise, 3.79. So now, so it is anti-clockwise, so minus 311.85 minus 311.85. So here UDL is acting so clockwise, so 30, so our UDL is 30 into 6. To convert the point load, we need to multiply 30 into 6. So our UDL is always act at a distance of L by 2. It means 6 divided by 2 plus it is also clockwise. 15 into at a distance of from here to here is, so from here to here is 4. Here to here is 8. So it means from here to here become it's 4, and from here to here is point C up to here is it's 4. It means the point load is acting at a distance of from here to here means 6 plus 4 is 10. 15 into 10 plus here also one point load, 10 into from here to here distance is 6 plus 8 plus 1, 15. So it will be 15. So here it is acting clockwise means positive 3.79. So minus RD is, it is anti-clockwise. So RD into at from here to here total distance is 20. So now is equal to 0. Now calculate this, it will come out as 36.59 kilonewton. It is positive, it means upward. Similarly, so for find outing the RD, we need to take the summation of all the vertical force is equal to 0, upward positive. So here RA and RB are moving upward, we need to take the positive. Here point load, the UDL, if you convert it into point load, it will come downward, and the point load is also, it is downward, it is also downward. So I will show how to do this. RA plus RD value we got was 36.59 minus the UDL is there, so minus 30 into at a distance of 6, and one point load is there, that is 15, and another one is 10. So 10 is equal to 0. So simplify it, it will come out as, our RA will come out as 168.41. This is the RA value. So now we will calculate the shear force and bending moment diagram. So now we will go for the bending moment diagram. So I have already drawn the bending moment diagram. So for UDL it will come parabola like this. For point load it will come triangle. So to find out this maximum height, we have the formula WL square divided by 8. Our W is 30 into L is 6 divided by 8. It will come out as 135. For this we have the formula WL divided by 4. So W is 15. So L is 8 divided by 4. It will come out as 30. Maximum height of this is 30. And for again the concentrated load, we have the formula to find out this maximum height WAB divided by L. So substitute all the value, it will come out as 8.33. So this is the bending moment diagram. So we'll draw the net bending moment diagram. For that, by using the value of final moments, we'll draw the net bending moment diagram. So see here, our MAB value is minus 111.85. So we always need to see the first point. Here first point is A. So at point A minus 111.85. So always see here, whenever we want to draw the bending net bending moment, the sign convention will be like this. The negative value always comes above the neutral axis. So our value is minus 111.85 means it comes above the neutral axis, means it comes here. For BA we have 46.28, it is positive. So point B is here, it comes here. And for MBC we have minus 46.28. So at point B we have to see the first point, means first point is B. So at point B your value is coming, negative value is coming above the neutral axis. It also comes here at same point. And for MCB the first value is C, the first point is C here. At point C 2.10. So at point C 2.10 means it comes here. The positive value also comes above the neutral axis. For MCD our first point is C here. At point C again minus 2.10. So at point C minus value comes above the neutral axis. So it also comes here only. So last is MDC, we have the value 3.79. So 3.79 means it comes here. So now join all the lines. The net bending moment diagram will come like this. So now we'll go for the shear force diagram by using the reactions. So reactions RA values 168.41. So 168 means it comes here. And from point A to B when UDL is there, UDL means it always comes negative value. The diagram will come like this, 168.41. So here on UDL is there, it 30 kilonewton, carrying the UDL of 30 kilonewton. For that what we have to do is, so 168.41 minus UDL is there 30 into distance. So 30 into 6, so it will come out as minus 11.59. So minus 11.59 means at point B it comes here 11.59. so it will be, our graph will be, so it will be like this. So again from here to here there is nothing, it will come straight. Here one point load is acting 15 kilonewton. So again minus it, so minus 11.59 minus 15, it will come out as minus 26.59. so here again, so minus 26.59 it comes here. So from here to here is nothing, so it will come straight. Again point load is acting 10 kilonewton, again minus 26.59. so subtract the 10, it will come out as minus 36.59. so minus 36.59. so it comes minus 36.59. so from here to here nothing, it will come here. Again here on reaction RD is acting, that is upward. So we need to add is 36.59. So if you do, our answer will come out as 0. So our line touches the neutral axis. Whenever our value gets 0, it means whatever we have calculated till now is right. So this is how we need to draw the shear force diagram. So this is our shear force diagram. So shear force diagram. So if you like the video, like it, share it and subscribe for more videos. Thank you for watching.